Factors affecting C. Factors affecting the resistance of the material. See, you take a metal, right, in the form of fire. Length remains same, and length is constant, but area of cross section is varying. Now here 1000 electron, see here 1000 electron can flow, here 3000 electron can flow. That means current will be more. Here flow of electron. That means here more the area, less the resistance. Here less the area, less the resistance. Suppose the area of cross section is very small, flow will be very, very difficult. 10,000 electrons flowing through this much area is very difficult. High resistance. When the area decreases, here when the area increases, what will happen? More electron will flow or more charge will flow. Therefore, the resistance is inversely proportional to area of cross section. Therefore, for a given length, On the other hand, area of cross section is constant. 10,000 electrons are charges to flow and come back here, right? But same area, if you have larger length, it offers certain resistance. But here same 10,000 charges, it has to go through a long way. Therefore resistance increases. If your length is very less, therefore resistance is less. But the length is more, resistance will be more. Therefore, you can call resistance directly proportional to length of the conductor. Therefore, resistance of a conductor of a material, conductor directly proportional, inversely proportional to area of cross section. Resistance is directly proportional to length of the conductor. Combining these two, for a given material, resistance is directly proportional to length, resistance is inversely proportional to area of cross section. Combining this, resistance directly proportional to length, area of cross section. I am equating it, they are related, therefore I am equating. I will put one symbol L by A. This is called rho. We pronounce it rho. This is each metal, it is different. For a given metal it is constant. This is called resistivity of the material, or this is also called specific resistance of the material. Like character of what is that? So brick, you take a brick. Cement brick is different from mud brick. Both are brick only. That is more strong this way. That is a mud is weak. Metal brick more strong. Metal mixed brick. Therefore, different material have different resistivity. It's called, it's a constant. Now, what is the unit of this? Length is in centimeter or meter. Area is what? Centimeter square or meter square. Resistance is what? Ohm. Okay. Now, I will write in SI unit. Resistance, ohm. Rho. Rho is specific resistance. Length is in meter. Area of cross section, meter square. Get cancel, cross multiply, ohm meter, rho. Therefore, unit of specific resistance. What is the unit of specific resistance, or unit of resistivity is what? Ohm meter. Right? See, now you take material, length is 1 meter, this is 1 meter. Therefore, area of cross section is what? Area of cross section is 1 meter square. Now this length also 1 meter. Now this is a cube of the material, isn't it? Now I will write it here. This resistance is how much? its value is around 15 ohm. I do some experiment. Okay, some material. The material whose area is how much? Area of cross section 1 meter, 1 meter, 1 meter square. Length is 1 meter. Now you substitute in this formula. What is this? Resistance I have calculated. That is 15 ohm. Rho, length is 1 meter. Area is what? 1 meter square. Therefore, what is the value of rho? Rho is what? 15 ohm meter. Therefore, the material whose specific resistance or resistivity of the material is what? 15 ohm meter. How to define? How to define specific resistance? I want to define specific resistance. Specific resistance of the material. Very simple. Here I write length is equal to 1 meter. Area is equal to 1 meter square. Then what will get? R is equal to rho 1 square. Rho is equal to R. Therefore, resistivity, that is resistivity of the material, is resistivity of the material, specific resistance of the material is equal to or numerically equal to what is this? Resistance of the material, that material of length what? 1 meter or unit length or 1 meter square area or unit area. Therefore, specific resistance of the material is numerically equal to resistance of the material of unit length and unit area of cross section. Or simple one way, it is a cube, no, unit cube, no. Therefore, specific resistance is resistance of the unit cube of the material. This is resistance of unit cube of the material, impure material. Therefore, here it looks bit higher, but if you properly understand, you can face any type of competitions, both what CBSE, ICSE, and SSLC, and railways exams, and National Defense Academy, and all type of competitive exams, and scholastic aptitude to SAT exam, SAT 1 and SAT 1, 2, international exams. All the exams you can do it. Again and don't study. You seriously study. You make an aim, what you want to become. You are not going to stop at this age. Therefore, with this particular topic comes more than 50 exams of all different type of exams they'll ask you in the international level from local. Therefore, local to global way you have to do, because now we are living in a global village. You can communicate to any persons across the globe through internet and mobile and all that. Therefore, you become read in depth, and not for only for the exam point. Apply your research mind. It will help you in all sphere of your life. And if you have any doubt, please ask your class teacher, your friends, and communicate with the different teachers. And I am very much thankful for the teachers from Vijaya College and National College and MES College, those who are constantly helping me to clarify my doubts. And as on when any mistake if they observe, they personally call me and they're telling, sir, you teach this method. And a lot of students are teaching me. Therefore, I learn from students, teachers, and from common people the method of teaching. Therefore, what I observe is each one teach one. That formula you apply and do it. Thank you.